All right, you guys, in the previous example to this section, all right, we covered a polynomial inequality. We graphed it as well as solved it algebraically. So now we want to do the same thing, but this time with a rational, okay? So this time our problem says solve x minus 1 over x squared minus 4 is greater than or equal to 0 by graphing r of x equals x minus 1 over x squared minus 4, okay? So we're going to follow the same steps we followed in the previous problem. So before we begin, we need to make sure our inequality has 0 on the right-hand side of it before we start. We do here. So we're good. Okay, we don't have to move anything. All right, the next thing we want to do is we want to follow the same steps that we did when we graphed rational functions. Okay, so let me write it first. Okay, so when we solved rational functions, the first thing we wanted to do is we wanted to factor everything, okay? So if I look at this problem, the numerator is already completely factored, so there's nothing I have to do. But the denominator is difference of 2 squares. All right, so I factored it. Then I'm going to check for any common terms that appear in the numerator and the denominator because I want to put it in lowest terms. There are no common factors in the top and the bottom, so I'm good. I'm in lowest terms. All right, we don't need to find the domain here. They didn't ask us for it, so we don't have to, okay? Now, some other things we need to find when we've been given a rational is we need to find the asymptotes, okay? So the first asymptote I'm going to try to find are my vertical asymptotes. And remember, to find vertical asymptotes, you set the denominator equal to 0. And then you solve. So I'm going to say x minus 2 times x plus 2 equals 0. It's already factored, so I'm going to set each one of those factors equal to 0. And then solve for x. Okay, so I have 2 vertical asymptotes. Okay, the next thing I need to decide is if I have a horizontal asymptote, an oblique asymptote, or neither. Okay, so I'm going to look at the degrees of my function since nothing canceled. So my degree in the numerator, let's change colors actually. So my degree in the numerator, all right, is 1. If you don't see an exponent, it's understood to be 1. And the degree in the denominator is 2. Okay, since the larger degree is in the denominator, okay, you're going to have a horizontal asymptote, okay, and it's automatically going to be at y equals 0 because that's where the larger degree is. It's in the denominator, and if it is, your horizontal asymptote is at y equals 0, okay. Now, if they were to ask us, does this function have an oblique asymptote? We would tell them no, because it already has a horizontal asymptote, and remember, no hos. You can't have both a horizontal and an oblique asymptote on the same graph. Okay. All right, the next thing we're going to find are the intercepts. Okay. All right, so I'll find my x-intercepts first. Okay, to find x-intercepts, you set y equal to 0 and solve. So we're going to have 0 equals x minus 1 over x minus 2, x plus 2. All right, I can put 0 over 1 and cross multiply to solve this. So 0 times the denominator is 0. 1 times the numerator is x minus 1. And then I'm going to solve for x. So x equals 1. So my x-intercept is at 1, 0. Okay. Next, I'm going to find my y-intercepts. Okay. To find y-intercepts, you set x equal to 0. So I'm going to have r of 0, which is going to be 0 minus 1 over 0 minus 2, 0 plus 2. So the denominator is going to give me negative 1. I mean, the numerator is going to give me negative 1. And the denominator is going to give me negative 2 times 2, which is negative 4. And a negative divided by a negative is positive. So positive 1/4. So my y-intercept is 0, 1/4. Okay. All right, while we're already solving everything out, we can go ahead and determine what the behavior at the zeros is going to be, okay? So at our x-intercept, all right, remember, if you want to determine what the behavior is going to be, you look at the multiplicity, okay? So the multiplicity on the 0 where x came from, the multiplicity here on this factor is 1. So since m is 1, that's odd, which means our graph is going to cross, okay, the x-axis at that point, okay? Now we can also look at the behavior at the vertical asymptotes, okay? So if we look at our vertical asymptotes, both of these degrees are 1. So the multiplicity is 1, which means that our function is going to clash when it approaches these asymptotes, okay? Which means that they're going to approach different infinities as they approach those vertical asymptotes, okay? All right, so now that we have most of our information, we need to draw a number line so we can figure out our intervals of where our graph is going to be either above or below the x-axis, okay? All right, now on this number line, you're going to put your x-intercepts, if you have any, your vertical asymptotes, and any holes, okay? So I have 2 vertical asymptotes, and I have 1 x-intercept. All right, and I'm going to put those numbers on my number line the way that they would naturally occur. So -2, 1, and 2. All right, when I did that, I created 1, 2, 3, 4 intervals, okay? Those intervals are, -infinity to -2, -2 to 1, 1 to 2, and 2 to positive infinity, okay? Now we're interested in where the graph is going to be either above or below the x-axis. So I need to choose a test point. It doesn't matter what I choose. I just need to make sure that the value I choose actually falls in that interval. So here I'm going to choose -3. Here I guess I'll choose, I can choose -1. That'll make that easier. Here I'm going to choose 1.5. And this is a 2. So here I'm going to choose 3. Okay, so remember, you're plugging these values into your inequality to see if you get something true. All right, so I'm going to plug in -3 minus 1 over -3 squared minus 4 is greater than or equal to 0. All right, so I don't particularly care what the number is. You can. I'm really just interested in the sign that the graph is going to take. So a -3 minus 1 is a negative number on the top. -3 squared is +9, and 9 minus 4, that's a positive value. A negative divided by a positive is a negative number, okay? And a negative number is not greater than 0, so that's false. So I don't like this region. I don't want to include it in my answer. All right, let's try the next one. So we have -1 minus 1, -1 squared minus 4. Greater than or equal to 0. So a negative minus a negative is negative. -1 squared is 1, and 1 minus 4, that's a negative number. And a negative over a negative is going to be positive. And a positive number is greater than or equal to 0. So that's true. I like this region. Okay. We're going to try the third one. So we have 1.5. Minus 1, 1.5 squared minus 4 is greater than or equal to 0. All right, so 1.5 minus 1, that's going to be a positive number. 1.5 squared minus 4, that's going to be a negative number. A positive divided by a negative is negative. And a negative number is not greater than or equal to 0, so that's false. So I don't like that region. All right, and then I'm going to try the last one. So 3 minus 1 over 3 squared minus 4 is greater than or equal to 0. So that's a positive number. And 3 squared is 9. 9 minus 4 is positive. A positive divided by a positive is a positive number. And positive numbers are greater than or equal to 0. So that's true. So I like that region. So when it comes to my solution, okay, I only want the intervals that make it true or intervals that told me that I was going to be above the x-axis, okay? So when we found that these intervals were either negative or positive, we were actually finding if the graph sat below the x-axis or above it. So for false, we were below the x-axis. For true or positive, we were above. Negative, we were below. And positive, we were above. Okay, so now I can take all of that information, okay, and graph it, because remember, they wanted us to show them the picture. All right, so I'm going to draw my coordinate system, and I'm going to put all the information that I found on it so far. All right, so we had 2 vertical asymptotes. Let me draw those in with a different color. We had vertical asymptotes at +2 and -2. And I'm going to draw those in with dashed lines. Okay, so that's x equals -2, x equals +2. All right, I had a horizontal asymptote at y equals 0. That's the same thing as the x-axis, so I'm just going to draw dashed lines out from it to continue that. Okay, now I'm going to plot my points that I found. So I had an x-intercept at 1, 0, should be here. And I had a y-intercept at 0, 1/4. So if that's 1, 1/4 is about here. Okay. And now I can try to draw in the rest of my values. Okay. Rest of my function. So we said in the interval, so let me highlight this, from -∞ to -2, okay, we should be below the x-axis. So when I go to draw my function, I should be below the x-axis, and I'm going to fall in between my asymptotes. So I'm below the x-axis, okay? All right, for between -2 and 1, okay, we said that we should be above the x-axis. So when I go to draw my function, -2 is between this first asymptote on the left and this x-intercept, and I should be above. So I'm going to draw my function through the y-intercept to this point, and you'll see that I'm above the x-axis. I also know this is the right way I should draw my graph, because remember, at these asymptotes, we said that our graph should clash. So this clashing motion, where I'm rising as they're hitting that asymptote, they're heading towards different infinities. Okay. All right, the next interval that I have is from 1 to 2, and I should be below the x-axis. All right, so 1 to 2 is at this x-intercept and this vertical asymptote, sorry. We should be going down. We should be below the x-axis. Oh, that's kind of crooked. Okay. And then in our last interval, okay, from 2 to infinity, we said we should be above the x-axis. So I should be there, okay? Now, remember, we're graphing it, but we're also tasked with answering the question, where is our problem greater than or equal to 0? So remember, the inequality we've been asked to solve is x minus 1 over x squared minus 4 is greater than or equal to 0. Now, because they asked us for is greater than or equal to 0, they're asking where is it above the x-axis, okay? Well, we can look at our picture and determine where we're above the x-axis. We're above the x-axis here, and we're above the x-axis on this curve. So we have to be able to tell them our answer in interval notation, okay? So we always write it in terms of our x values. So this first curve here, okay, begins at x equals -2. So we go from -2 all the way to this x-intercept, which is 1, okay? We are going to put a parentheses around the -2 because there's a vertical asymptote there, okay? Anywhere you have a vertical asymptote, it will always get a parentheses for the interval notation because you can't include it. It's a point of discontinuity, okay? And then we're going to get to 1. When we get to 1, we're going to put it in a bracket, okay? The reason we're going to put it in a bracket is because we can include it and because our inequality symbol was greater than or equal to. And our function actually equals 0 here, which is okay based on how our problem is written, okay? Then I'm going to write a union, and I need to describe this second curve. This second curve starts at positive 2, okay? It's going to get a parentheses because there's a vertical asymptote there, and it's going to go all the way to infinity, and I'm going to put a parentheses around it, okay? So for this problem, this would be my answer in interval notation, okay? So if they ask you to graph it, okay, you need to completely graph the function and then determine whether you're looking at the part of the graph that's above the x-axis or below it, okay? Now, if we were to do this same problem analytically, okay, we could cut out some of the steps here, all right? So if we were to solve it algebraically, okay, then we would need to find anything that would divide the x-axis. So you would need to find if it had any vertical asymptotes, X-intercepts, or any holes, okay? So we did that when we found the vertical asymptote here. We found those parts. When we found those two, we found our X-intercepts here. Okay, we had 1. And this graph had no holes, okay? So remember, from those values, we then created this table, okay? So the same way that we solved a polynomial inequality, okay? When we graphed the table out, same thing we did here. So we were looking for the parts or the intervals that made our function true. We found that in this second interval and the fourth interval, okay? So we had already pretty much solved this problem without seeing the picture just by doing the table. So if you were doing it analytically, you could have stopped algebraically. You could have stopped at the table and just got your intervals that made it true, and you could have stopped there. So the picture was just specifically because they told us to graph it, okay? So once I would have gotten this table and figured out what my intervals were, okay, from the table I knew that -2, 1 was an interval, and I also knew that 2, positive infinity was an answer, okay? And then I would have to assign parentheses and brackets accordingly, okay? So you have to pay attention to where these numbers came from, okay? So those numbers are vertical asymptotes where x equals -2 and +2. So when you go to assign either parentheses or brackets, vertical asymptotes are always going to get parentheses, regardless of what your inequality symbol is, because those are points of discontinuity. Your graph does not equal those values. It can't, okay? So automatically, I would have put parentheses here, okay? And I automatically know parentheses always go around infinity, all right? So then I would have to look at 1. Well, 1 is an X-intercept, okay? Okay, so X-intercepts, depending on what your inequality symbol is, are either going to get a parentheses or a bracket. They could get either one. Now, because our inequality symbol was greater than or equal to, okay, and our X-intercept is actually where our function equals 0, 1 got to have a bracket, okay? If it would have been a strict inequality, it would have been a parentheses, okay? So a union. So you can see that we get the same answer either when we do it algebraically or when we graph it. So like I said in the previous example, it's completely up to you. It just depends on what the prompt of the problem is. If they ask you to graph it, then you need to graph it. If not, you can do it algebraically and skip the graph altogether. Okay, cool.